Welcome to clickmyproject.com. Now we are going to discuss about the title High Throughput LDPC Decoder Architecture using Efficient Comparison Techniques and Dynamic Multi-Frame Processing Schedule. Now we are going to discuss about the abstract of this title. This project proposes dynamic multi-frame processing schedule. This schedule efficiently utilizes the ladder LDPC decoding with minimum pipeline stages, and this project presents architecture of block level parallel ladder decoder for irregular LDPC codes. This code can be to support various block lengths and code rates in Wi-Fi standard communications. The system presents an efficient comparison techniques for both column and row ladder schedule, and based the high speed circuits to compute the low minimum values from multiple input required for row ladder processing of hardware friendly min-sum decoding algorithms. The system utilizes 3 pipeline stages to evaluate this scheme. The system shows the result as good speed with low areas and compared to state-of-the-art circuits in this project. The system proposes an efficient comparison technique to be used in the construction of high-speed circuits and minimum values with smaller number of pipeline stages. This resulted in lower latency and good frequency scaling. A dynamic multi-frame process of LDPC decoding algorithm is used to remove the pipeline bubbles and minimum the memory overheads. The BER performance analysis of this decoder for various coding rates has been performed in adaptive wide Gaussian noise channel environment. Thus, in wireless communication standards like IEEE 802.11, WiMAX and Wi-Fi uses the low density priority check decoders. This type of decoders are used to achieve high throughput and high speed in different wireless communication standards. The fast decoder performance is achieved by using the min-sum algorithm, and these decoders are used to achieve very less minimum communication standards. Now we are going to discuss about the flow of the LDPC decoder. The flow shows the full operation of the decoder. In this flow, the first module is CNU. CNU means check node unit. In the CNU, we can achieve 3 pipeline stages. Using these stages, we can provide the 24 combination as output, and the outputs are stored in the memory unit. So in the 3 pipeline stages are performed with the MUX network, register circuits, min-sum algorithm blocks. So min-sum algorithm is achieved by using this CNU check node unit, and followed to the CNU unit variable check node unit is used. VNU. VNU means variable node unit. In this VNU block consists of MUX network, linear buffer, summer, adder and consolidated networks. The output of CNU is divided into 4 combinations and given to the VNU block. Then the VNU block provides 2 input, one gives 5 outputs and other one gives 24 bit outputs. The VNU and the CNU block provides major role in high performance in the LDPC decoder. Then followed to this VNU, memory register elements are used. Then the memory architecture, the high throughput LDPC decoder has memory unit to store 24 combination of input, and also it uses to read and write 24 combination input in memory. The RAM memory is used to read and write 24 combination of input in 5 bits in the high throughput LDPC decoder. In the LDPC memory architecture, the input is provided from CNU block and the output of data stored in RAM memory is given in VNU block. Then finally the LDPC decoder consists of CNU, VNU and the memory architectures to provide the high efficient decoding operation in the wireless standards. Now we are going to see the simulation and implementation result of this LDPC decoder. This LDPC decoder is designed using the Xilinx 14.2 software. So for that, first we have to click to this LDPC Xilinx ISC project. Then the programming window will be opened. In that programming window, first we have to see the simulation result. So for that, click to this simulation and double click to this simulation behavioral model. The simulation window will be opened. In this simulation window, the 24 combination inputs are given. Now we are going to give the control signals. So first give the selection as 1. Then give the clock signal as 1. Then we have to give the reset as 0. Then we want to give the enable line as 0. Then give read write input. Address input. Then give run. So finally the decoded output will be presented. Now we are going to see the implementation result of this LDPC decoder. For that, click to this implementation. Then click to this synthesis existing. Give run. After the synthesis will be run, then we have to see the RTL schematic diagram. For that, click to this view RTL schematic diagram and give run. OK. Then create schematic. The RTL schematic diagram will be shown. This is the full view of the RTL schematic diagram. Now we are going to see the technology schematic diagram of this LDPC decoder. For that, first we have to click to this view technology schematic and give run. Give OK. Then give add and create schematic. This is the full view of the technology schematic diagram of the LDPC decoder. This full view shows the technology schematic diagram of the LDPC decoder.